finished up. So now parts are getting smaller, features are also getting smaller. So let's see how Walter Germany have responded with the latest addition to their world-leading range of drilling products.
So I'm pleased to introduce our micro drills DB133 and our pilot micro drills DB131. Let's start with the main cutting edge. So we make a special edge preparation, means we make a small rounding on the main cutting edge that stabilize the cutting edge and will remove all the micro cracks we have. So that gives a process reliability. The next is the internal coolant. Internal coolant will help us to improve the cutting data. So when we can improve the cutting data, we also can improve the productivity to the customers. And will also help to bring right on the right place the coolant where we need it. And you see we have two channels down to the cutting edge. And on the end we have a so-called a coolant chamber. And that helps us to bring the coolant very quick through the drill and will increase the flute rate. To the flute design, that is important for the chip breaking. So that will generate very small chips. And we have always imagined we are talking about a diameter range of 0.7 millimeters. So there's not a lot of space for the chips. Therefore, we have to have very short chips which are easy to evacuate out of the hole. And in addition to that, to the short chips, we can use that drill also in different kind of materials. So we have ISOP materials, we can use it in stainless steel, cast iron, non-ferrous material, as well as in high temper alloys. So that gives you also a kind of a universality of DB133.
There we have it, the new micro drills. But before we get into the micro drills, hello to everyone watching on Instagram and all the other social channels live. Please do get involved, ask your questions. We're talking micro drills, but that doesn't mean you can't ask questions about products we've already talked about, or in fact, things we're going to talk about later on in the show. But micro drills, you know, my first question, what are the design elements you have to consider when bringing a new micro drill to market?
Well, the micro drill, the brand new micro drill DP131 and 133 that we've brought to market, Joe, it's the design elements. It's a new point micro geometry, polished flutes, and a brand new coating there, so it increases productivity, swarf evacuation, etc.
It's exactly that. So components, Lindsay mentioned earlier, components are getting small, watches, mobile phones and all the rest of it.
Yep.
So does that mean the market's bigger now for micro drills?
I think it's pretty much an untapped market for a lot of manufacturers, a lot of cutting tool manufacturers. It's a market that has deemed the investment into developing these new products, and they are a major advancement on our previous micro drills, which was a smaller product portfolio.
And for people who are unaware maybe of your history of the Walter business, obviously you're coming from a position of strength with the Titex brand.
Yeah, absolutely. Walter brand image is a multi-brand image. So we have Walter Prototype and Walter Titex. So they're all brand names in their own right, known out in the industry as market leading. So this is a Walter Titex drill. So again, using all the same technology, all the same design and performance benefits that we get from the Titex product portfolio, and advancing it forward.
And just a free tip for anyone watching, you know, is there any limitations? What are the setup requirements of a micro drill?
It's because of the size and the nature of the size of the drill. Then obviously there is accuracies that you need to be, run outs on machines and things do need to be better generally, but in general they are quite forgiving. But you do need a slightly more accurate setup than if you were going to put a 10mm drill down a hole.
Yeah, and maybe some coolant considerations also. Yeah,
I mean the range we have through coolant capability from 0.7 to 1.984.
That's incredible.
Yeah. I can't even see it.
Yeah, top marks to the cameraman, because I can't see it here, but I'm sure you can at home.
Yeah, so and up to 12 times D as well on these diameters. So yeah, swarf evacuation is key when you're drilling any diameter, any size, but particularly when you're small diameters. So the coolant supply and the polished flutes enable that swarf evacuation and prevent drill breakage. Yeah,
there's an argument. This is eliminating EDM drilling. There's certain diameters in certain materials you wouldn't have dreamed of drilling a number of years ago. Whereas now I've seen your drills drilling all materials from aluminium to the toughest imaginable.
Yeah, it's funny you say that, because we have got a customer in the northern region that had a spark driller for removing taps from broken taps from their components, and with the Titex technology, the Walter Titex technology, they've actually sold the machine because of the lack of breakages in the processes. So
yeah, so you briefly mentioned the range earlier, but where does it start and where does it finish in terms of the diameter to length ratios and things like this?
So what you've got is two separate products in the full range. You've got DB131, which is a pilot drill. It's a 2 times diameter pilot drill. It's fully coated up the flutes, and as I say, this is used as a pilot drill. It's a 150-degree point angle, which makes it perfect for following it with a deep hole drill. The drill is ground to a P7 tolerance, so it's a plus tolerance. Again, perfect for pilot drilling for deep holes. The DB133 we have the diameters of 0.5 to 1.984. On the DB133, it starts at 0.7 to 1.984 with through coolant, and down to 0.5 with solid drills. 5 times D, 8 times D and 12 times D.
Mm-hmm. A question we had on Twitter yesterday, when they saw the products we're going to be promoting, it talked about the importance of being on center on a lathe, on the sliding head lathe.
Yeah, it is important in any drilling application that you get the center heights right, you get the alignments right. More so with a micro drill, because of the nature, it's not as strong as a large drill. Obviously, there's no bulk strength there.
Sure. And are there any limitations now?
Is in regards
Well, in terms, I'm thinking materials in particular.
materials,
but-
the range is designed to run across the full range of ISO materials, so P, M, K, S, N, non-ferrous, plastics and harder materials. What we do say is we recommend on the stainlesses and the super alloys that you would use the through coolant drills, not the solid drills, apart from the piloting. So
yeah, from my perspective, to be honest with you, I'd always use the through coolant. When you're down at this diameter, you've got to get that swarf back.
Always, yeah.
If that drill fails, it will be down to your swarf control.
Yeah.
So why not just use through coolant?
yeah, the vast majority of machines now have got through coolant capabilities. Very few machines go out into the market without it. So yeah, you know, the cost of the drill, the price of the drill is no different. So why not? You may as well use the coolant, and it gives you two things. It gives you better productivity. You can run quicker, and the tool life and the security of the process.
And these drills, they don't just come onto the market overnight. There's a lot of R&D, a lot of development in Germany on this product. So presumably you've benchmarked this against other drills, maybe even your own drills. So how's it come out?
When any product is developed in Germany, there's a full background benchmarking exercise. So they will always benchmark against our previous product to ensure that you are going to get the benefits out of a brand new product. Also, they'll identify with market research the main runners within that industry in that product range and always benchmark against those. And they will never bring out a new product from Germany that is not going to be an improvement on the competitors.
Yeah. And we have a question.
Yeah, we've had a question come in. Thank you. Welcome everybody. If you've just tuned in, we've got lots to come. We're going to be talking later on with Anna about tool management, and we've also got some Kamara, which I know that you, Joe, absolutely love. Before we got here, we stayed in a hotel last night, and you were like, oh my gosh, the software is amazing. So we've got some industry firsts as well coming up, but we do have a question coming in, so we do encourage you to write your questions in. So Artem Agin has written in, what is Walter's view on additive built cutter bodies and or tool holders?
Yeah, thank you for that one.
Well, blame Artem, not me.
Yeah. Well, from our perspective in GB, we're not, because it'll be a development side, we don't always get involved in that side of it. But I know there's work going on to see whether there's the cost benefits and the strength benefits of doing that. I know there's work going on, but any more information than that I can't say.
Mm-hmm. So just on the micro drills, stocking levels, it's quite important.
Yeah. All the products you'll see today are only released once stock has been built. So there's a period of stock building before the release date. The DB133. The DB131 and 133 in certain sizes have been available since January, but it's a full stock standard range.
Right, brilliant. Okay, thank you so much for all your questions. Keep them coming in. We do encourage you, and a very good, is it morning still? It's still morning, isn't it? Good morning to each and every single one of you.